Welcome to a new lesson. In the previous lesson, we discussed the algorithm and logic of the program, and here we discuss the actual code of the program. Let us start with the map class, that is word count mapper. It starts with import statements. These portion of import statements import Hadoop specific data types for key and value. In Hadoop, the key and value data types can be only of Hadoop specific types and are tailor-made for Hadoop systems. What was the need and why didn't we use the already present Java types for key and value would be understood later in the course. For now, just understand that long writable is something similar to long field, which is used to take care of a long number, and text is something similar to string in Java, which is used to carry sequence of characters. And int writable is a data type similar to integer in Java. Next, every map class would extend mapper class and override the map function. These here are the type parameters which specify the Hadoop data types. This would have input key and input value data types which Hadoop supplies to map, followed by output key and value data types. So here the data types for input key is long writable and input value is text. And data type for output key is text and data type for output value is int writable. We would declare the two fields which we require in the processing logic. When we need to override the map function has the parameters as input key and value and context. The data type of input key and value should match the above mentioned data type parameters. Role of context is to catch the output key and value pair. After this is the processing logic of map function. We tokenize the string into words and write it into the context with word as key and 1 as value, as we had discussed earlier in the algorithm. So the idea is to understand the basic structure of map class, and so you can customize the same for a different logic and everything would be easy. First point is to declare the type parameters, which are data types of input and output key values. Second is to override the map function with the processing logic you require. Make sure that the first two parameters are the input key values and their data types should match with the above type parameters declaration. Third is to write the logic you need and end it with context.write method to write the output key and value pair. Next, let us look at the reducer class. If you got the main theme of map class, reducer class would be easier to relate to. Every reduce class needs to extend reducer class. Following it would be the type parameters, which would specify the Hadoop specific data types for input key and value, followed by the data types of output key and value. Then we need to override the reduce function. The parameters to reduce function are the key, followed by the iterable field of values. As we discussed earlier, the input to reduce function is key and list of values, and so here you see that the values is specified as an iterable field. The third parameter to reduce function is the context, which collects the output key and value pairs. Followed by that is the logic, which we have already discussed. I want you to note that in processing logic, for almost every solution, you would have the exact same loop which iterates over the values. In this case, we just add the values into the sum field. And after all the values of a particular key are processed, we output the key and value pair through context.write method. So I'll summarize the structure of the reducer class, which you can apply to any solution. First, we specify the Hadoop specific data types for input key value and output key values. Please note that it is important that the data types for input key and value of the reducer should match the output key and value of the map function. Second, we need to override the reduce function. The first two parameters are the input key and value, and the third one is context. It is important that the data types mentioned above should match the data types mentioned in the function. Third, we just need to initialize properly and change the logic in the for loop as per the solution, and use context.write method at write points to output the key and value pair. Next, let us look at the driver class. The structure and the flow of driver class is absolutely simple if you understand the job class and its function. You can imagine job object as a dashboard with levers to control the execution of the job. And the idea of driver class is to set the job parameters so that Hadoop can take it from that point and execute the job as specified by the programmer. And so you would see that is what we are doing in the whole driver class. We first declare the job object. Then we would be using the setByJar class method and pass the name of the driver class. This helps identify the jar file when it is distributed across the cluster. Then we set up the job name, which would be visible on the UI. Then we set up the mapper class and the reducer class by passing the names of the map class and reduce class we just designed. Finally, we set up the output key value data types by using the method setOutputKeyClass and setOutputValueClass. Now this output key and value mean the output key value data type of the job. So in turn, it means the output data type of key value pair of the reducer. So we need to make sure that these values and the one we declared in the reducer class should be the same. Then we use the method FileInputFormat.addInputPath and addOutputPath to add input and output files for our job. These would be passed by command line arguments. Job.waitForCompletion is the method which actually triggers the submission of the job to Hadoop. And that is all a programmer needs to code. If you notice that there is nothing a programmer needs to do to distribute this over the cluster and manage the network input-output. All is managed by Hadoop, and that is what makes Hadoop special. Another wonderful thing is that this code is scalable. If it works on a single machine, it can be scaled to thousands of machines without a change of line in the code. Now let us try to run this program, which is basically exactly the same as we did in the lesson how to compile and run a program, which we did in the section setting up Hadoop. I'll first of all create the jar file. For that, I would go to Hadoop Experiments, then right-click on it, and go to Export, then click on Jar Files, and then on Next. The name is already present, and so I'll click on Finish. I would overwrite the jar file. Now at this point, I'm already in the bin folder where I created the file, so I'll do an ls. This shows the word count.jar file. Let me just do an ls on Hadoop file system. Make sure you have run start-all.sh and all your daemons are up and running before you do so. Here we see the in file, which we had already created in the lesson compiling and running a program. Let me just do a cat on that file. So it has contents as to be or not to be. Now let us run our program on this. So for that, I'll type in Hadoop jar file name, driver class, input and output files. So here it would be Hadoop jar word count.jar word count in and out1. I'll make output as out1 as out directory is already present. Here we see the run of the program. Now let us again do an ls on the Hadoop file system. And there we see the out1 directory. Let us do an ls on the out1 directory. And there we see the part file which contains the output. Let us cat that. And there you see the final result. For now, I would suggest you to experiment a little with the input of the program and see how the result changes.